In this video, we're going to go back over data transformations. We're going to look at what they are, why do we need to use them, what type of transformations are possible, and most importantly, how do we actually do it on the calculator. So a data transformation is used if we have a scatter plot with a relationship on it, and the relationship is clearly non-linear. By non-linear, we might be seeing something that looks like this. So we may have our x and y axes like this, and we may have a relationship where the points are curving upwards, something like this, and fitting a straight line through the points is not really an option. Instead, we'd prefer to fit some sort of curved line through. We can't fit a straight line that represents the relationship. So what we're going to do is what's called transform the values on the x-axis or the y-axis, and what we're looking for is to go from a relationship where the points are curved to a relationship where the points may become more of a straight line. Not a perfect straight line, but they'll become more linear. And therefore, we've transformed either the x or the y-axis, and we've got a relationship that's more linear. Now, when we're talking about transforming values, we're doing something to the x values or the y values. And the options we basically have, we have one of three options. We can square the x values or the y values, so we end up with squaring x, so we get an x squared axis or a y squared axis, and this is what we call a square transformation. We can divide the values, the x values or the y values, by 1, so often we call this a 1 on x or a 1 on y. The official term that we need to look for in the exam is a reciprocal transformation. So when we see this word reciprocal, it's meaning 1 on x or 1 on y, and it will normally tell us which axis to do the reciprocal transformation to. And the third option is we take the log of the x or y values. Now, log is a concept that we don't need to know what it is in further, we just need to know how to do it on the calculator. And again, we're looking for this word logarithmic, which is kind of the official term. So we have these three things, and we can take our x and y values and we can square them. So we can square them, we can divide them by 1, or we can take the log of them. Now, normally you won't actually need to work out which one to use. If it's in exam 2, the short answer exam, the question will tell you which transformation usually. Exam 1, there may be some questions which ask you which one would be suitable. So I would suggest that you have a table like this in your book of notes, and we've clearly got here 4 different types of scatter plots. Each of them are non-linear. And depending on the shape of the original scatter plot, so if it's curving upwards like this, then the best ones to try are either an x squared transformation, a log y, or a 1 on y. If the data is sloping like this, then again we could try a y squared or a log x or a 1 on x. And we have similar transformations that work for this shape or this shape. But as I said, it's unlikely, certainly in exam 2, you will most likely be told what transformation to try. In exam 1, multiple choice, there may be a question where they show you, they might have a question where the data looks something like this. And the option, and it might say which transformation should you try, and it might give you these 4 options, and it might also give you this one, which is clearly wrong for that shape data. So it's very worthwhile having this in your book, this table, but probably more so for exam 1. Okay, we're going to look at a couple of past exam questions to see how we do these in the calculator. So let's go to a question from 2008. Okay, so here's our question. So we have a table here, and let's read the question. The number of hours spent doing homework each week, which is in this column, and the number of hours spent watching TV each week were recorded. The results are displayed in the table, and the scatter plot is constructed as such. So here we have the table and the scatter plot, and we can clearly see a non-linear relationship where the points are sloping downwards, sort of in a curved line. Now let's scroll down to the questions. So what have we got here? The relationship between homework hours per week and television hours is clearly non-linear. A reciprocal transformation applied to the variable television hours can be used to linearize the scatter plot. Okay, what this means is we've just seen in our presentation back here that the word reciprocal, here's that word reciprocal, and that refers to a one on something. Now let's go back to the question. Reciprocal applied to the variable television hours. Here's television hours up here on the x-axis. So what this is talking about is a 1 on x transformation. It's telling us the question is apply this transformation to the data and determine the equation of the least squares regression line that allows homework hours to be predicted from the reciprocal of television hours. Okay, effectively it's saying do the data transformation and work out the least squares regression line for the transformed data. Okay, so let's go. So what we're going to move from is we had an original which looked like this. We had homework hours here and we had TV, and it was scrolling and it was sort of coming down like this. We're now going to leave homework hours as it was. We're going to do a 1 on TV, and we're going to hopefully get a more linear relationship. Now let's go to our calculator to see how we do this. Okay, so I have already put in the data. So this here, here's my table of data, and that matches perfectly with this table here. So I have my TV hours, and you'll see I've called this column TV, and I've called this column HW for homework. You can call it whatever you like. And I've put these numbers in. Now, as a little double check, I should have 20 values because it's recorded for a group of 20 students. And if I go back to my values, I can see that, yep, I'm in the 20th row by the time I finish, so that's good. Okay, first thing to do is, now this probably isn't a necessary step, but let's graph the scatter plot. So let's go back to the home page, put in a graphs and data and statistics page. Okay, on the x-axis I want TV, and on the y-axis I want homework, and that looks very similar, well it should look exactly the same as this scatter plot that they gave us in the question. They look pretty good if we compare them. Okay, now we don't want to compare homework and TV. We want to graph homework. We want to leave this as it is, and we want to change this axis to 1 on TV. Okay, so we go back to our listen spreadsheet. So I'm going to create a new column here, and I might call this 1 on TV. And you can, again, you can call it whatever you like. You might call it Recip TV. You can call it anything as long as it's got letters and there's no spaces. So I can't call it 1 on TV because it won't accept it with spaces. So I'm just going to call it 1 on TV. Okay, in the grey box, this is my formula bar. I want to write a formula in here that's going to transform all of these values in the TV column. So what I'm going to hit equals, and I'm going to insert a fraction. Okay, so I'm looking down the bottom here, okay? On the top of my fraction, I want 1, and the bottom I'm going to write TV, and when it comes up in bold, it's recognising it from the heading in column A. And it's now taken all the values here, so it's 6, and it's done 1 divided by 6. 28, 1 divided by 28. If you're getting decimals in this column, that's okay. That's okay. They should all be less than 1 though. They should all be small decimals. Okay, I'm going to go back to my scatter plot now, and I'm going to change this axis to 1 on TV. Okay, so what we have now, it's not perfectly linear, but it is certainly more linear than it was before. So I've now done the data transformation in the calculator. The next step is to get the least squares regression line for this scatter plot. Now I can do that straight from the scatter plot. If I press from here, I press menu, analyze, regression, show linear. Okay, and here is my equation. Now I'm going to write that down. So it's y equals 102.90 if we round that. So I'm going to write this down. So it's y equals 102.90x. So what I'm currently doing is writing down the equation, this equation here. So 102.90x plus 5.12. So this is the equation of the least squares regression line from the scatter plot where it's y and 1 on x. Now I've got a couple of things to do before this is not my final answer. This least squares regression line came from a scatter plot that showed a relationship not between y and x, but between y and 1 over x. So I'm going to replace this with this, replace the x with 1 over x, because, again, reminding you, this equation, which is here, this equation here came from this scatter plot, which is the relationship between 1 on TV, or 1 on x, and homework, or y. If we go back to the question, let's just have a look at the question. Apply this reciprocal transformation and determine the equation of the least squares regression line that allows homework hours to be predicted from the reciprocal of TV hours. And what they're looking for you to do is to write the equation of the line in terms of the variables. So they don't want to see y and x, they want to see words. So what we're going to do is replace y with exactly this word, homework hours. And don't take any shortcuts here, just write exactly the right variables they're using. Equals 102.9 times by 1 on TV hours plus 5.12. And the other way of writing this is to put the 102.90 up the top and something like this. And that is our final answer. So either one of these last two lines, either this or this, is your final answer. And you'll note as well one other thing. Let's go back to that exam question. We have written the coefficients correct to 2 decimal places. So there's our answer. Now the second part to this question, if a student spends 12 hours per week watching TV, use the least squares regression line to predict the number of hours that the student spends doing homework. So if they spend 12 hours watching TV, how much homework do you think they'll do? So we go back to our equation and we're saying, well, if they spend 12 hours a week doing TV, so their homework will be 102.90 divided by 12 plus 5.12. Let's go to our calculator and work that out. So what was it again? 102.90 divided by 12 plus 5.12, 13.695. We want to get this to 1 decimal place, so it would be 13.7 hours. So the answer to, so this would be 13.7, and we would write that in here, 13.7 hours, and that's just a 1 mark question, so just the answer is required. Okay, let's look at one more exam style question. So this is this time from the 2011 exam. It's a very similar sort of question. We've got a table of values, we've got a scatter plot given to us. It's about the average age of women when they first get married and the average yearly income in that country for 17 different countries. So here's country number 1, and you know their women are on average 21 when they get married for the first time, and the average income per person is about $1,750. And then we've got other countries. This one, women are a lot older compared with the first country. They're 31 years old when they get married for the first time, and they also earn a fair bit more. And we end up with this sort of curvy looking scatter plot here. Okay, let's look at the questions. It tells us the relationship between average age and income is non-linear, which we can see. A log transformation. So we're going to take a log. Can be applied to the variable income. Income is on the x-axis, so we're going to do a log x transformation. Apply this log transformation to the data, determine the equation of the least squares regression line, write the coefficients correct to 2 decimal places. And they've given us a sort of a structure. We need to fill in these 2 boxes. Okay, let's use our calculator to do the transformation. Once again, I've already put this data into the calculator somewhere. Here it is. Age and income. So direct copy, I should have 17 values, and I do have 17. So what am I doing? I'm doing a log x transformation. So I'm going to take all the x values and log them. Okay, before I do that, let's just do the scatter plot of age and income. Again, this is probably not essential, but we'll do it anyway. Age on the x-axis. No, it wasn't age on the x-axis, it was income on the x-axis. Income, age. Okay, there we go, and that looks a pretty good match for this scatter plot here. Yep, happy with that. Okay, non-linear, we're going to linearize it. Let's go to our calculator. So we're going to do a log x transformation, or we're going, and x is income. So I'm going to call this log income, in the formula bar, equals. Okay, now I'm going to type the word log for log. No, hang on. I'm going to do. Okay, I'm going to press. So I'll just show that again. Over on the keyboard here, above. So I'm over here. I'm above the 10 to the power of x button. There's a little word log. So if I press Control 10 to the power of x, it brings up a log. Always base 10. Always 10 at the bottom of income, and I type the whole word in and it comes up in bold because it recognizes it. Okay, again, it doesn't matter if you're getting this or you're getting decimals, it doesn't matter which one. Go back to my scatter plot. Instead of x and y, I want log x down here, so I'm going to change this to log income, and that's made the data a fair bit more linear. And now I want the least squares regression line of this data. So I press menu, 4 for analyze, 6 for regression, 1 for show linear. Okay, so let's just drag that up so I can read it properly. Here we are. So I'm going to write this one down. Y equals 5.89 times x. Y equals 5.89x plus 2.39. Okay, now again, I want to get rid of y and x. I want to use the actual words. So y was age, 5.89, and x was log of income. We might actually just get rid of this. Times log. Okay, here is my equation. So if I was asked to write the equation, that would be okay. That would be perfect. However, let's just check how they've want us to write it. So they've got average age first. So they've written it something like this: average age, and then they've got a box plus another box times log of income. So we need to read this carefully. The 5.89 is what's getting times by the log of income, so that's going to go here. And the 2.39 is the number by itself, and that's going to go here. Now, last question. Use this equation to predict the average age of women at first marriage in a country with an average yearly income of 20,000 per person. So if income is 20,000, what will age be? If income is 20,000, what will age be? So we're going to sub 20,000 into here, and we're going to work this out on the calculator. So how do we do that? We'll go to a calculator screen. So let's go back, oops. So it's, yeah, that should be a plus there as well. So 2.39 plus 5.89 times log, base 10 again, of 20,000. 27.72, what do I want it to? 1 or 2 decimal places? 1 decimal place, so 27.72 27.7 would be my answer. 27.7. Okay, so we've covered a couple of different transformations, a log and a reciprocal. Main thing is read the question carefully, get it in your calculator right, and just practice a few before you go into the exam.